Good morning, all. I welcome you for the lecture series in the course Production Technology. Today, we have an interesting topic, Fundamental Principles of GD&T. Normally, GD&T is abbreviated as Geometric Dimensioning and Tolerancing. It is a powerful system for precisely defining and communicating engineering specifications. In this presentation, we will explore the core concepts that form the foundation of GD&T and how they can be applied to improve product quality and manufacturing efficiency. So understanding datums, what is datum? A datum is a reference point or axis or a plane from which measurements are made and tolerances are established. So whenever we take any industrial drawing, we will have a set of dimensions of the feature. So in that, the dimensions are to be made with respect to a reference point, and that reference point we call it as datum. So datum are organized in hierarchy with primary datum as the most important reference. Datum targets, specific geometric features are designated as datum targets, which define the exact location of each datum. So applying geometric tolerance, tolerance is nothing but whenever a product is manufactured for a drawing, there may be a possibility of not achieving the dimensions exactly mentioned. For example, 30 mm diameter of a shaft, which is manufactured or fabricated in a lathe. So we will get maybe 30 point some 12 or 21 like that extra feature, or we may go up to 29 point something. So there may be a possibility of increasing the basic size or decreasing the basic size. This is due to three things: man, material, and machine. So these three things cannot be controlled always. So whenever we design a component, we give tolerances. That tolerance is of two types. One is bilateral tolerance or unilateral tolerance. So based on the tolerance, the machining part is done. So we have form tolerance that specify the allowable variation in the shape of features such as straightness, flatness, or circularity. And we have orientation tolerance that determine the acceptable angular or positional variation of a feature relative to datum. And we have location tolerance, define the permitted variation in the position of a feature with respect to a datum. So dimensioning principles, linear dimensions, angular dimensions, and geometric dimensions. Specify the size and location of the feature using linear measurements. Linear measurements include length, height, width, thickness, like examples. Angular measurements include the angular relationship between the features or the datums. So any inclinations or any tangent which is not parallel or perpendicular to any kind of references, they have angular dimensions. And geometric dimensions is precisely define the size, form, and orientation of the features using geometric tolerance. So we have tolerance zone, concept, visualization, and significance of the tolerance zone. We can see. So tolerance zone define the allowable variation of a feature, ensuring proper fit and function. So again, coming to the fits, we have three kinds of fits. One is interference fit, transition fit, clearance fit. So these three fits, how it determines how a two male and female part get assembled. And visualization is tolerance zones are graphically represented as geometric boundaries on engineering drawings. So understanding tolerance zone is crucial for effective communication and managing manufacturing process. So feature control frames, symbol. Feature control frames communicate geometric tolerance using standardized symbolic language. Dimensions, the frame includes information on the tolerance value, types, and reference datum. Datum reference are essential for proper properly interpreting and applying geometric tolerance. So what are the GD&T symbols and meanings? So we have a lot of GD&T symbols. A few are explained here. So straightness, specify the acceptable variation in future straightness. Flatness defines the allowable deviation from perfectly flat surface, ensures the acceptable roundness of a circular feature, establish the required angular difference between the features. So these are all the certain GD&T symbols and meanings. So key takeaways, precise communication. GD&T provide a standardized language for defining and communication engineering specifications. Improved quality, understanding and applying GD&T principles help ensure product quality and performance. GD&T support more efficient manufacturing process by clearly identifying the critical features and tolerance. So coming to the end of this session, I would like to summarize what we have seen. We have seen what is GD&T and the fundamental principles, datum, and geometric dimensioning principles, tolerance zones, and feature control frames, and few symbols which is used in GD&T. Thank you for your patient listening.